Hello and welcome back to part 2 of 6.1. I'm going to continue with the washer method. Okay, so you'll notice in this method, it's no longer going to be this solid circle that we're going to be, it's going to be a cross section. Now we have this little hole in the middle of our shape. Okay, and then the cross section of each of these shapes, each of the cross sections will be what we call the washers, right? Just like a typical washer that you would see like in a hardware store. Okay? So to start to process this, we have an outer radius and we have an inner radius, right? So what you see here in the notation, we have a capital Rx would be the outer radius, and then the lowercase rx, that would be the inner radius. Okay, so we have a method for figuring out the difference in the radii. Okay, so our formula, okay, similar to the disk method, but now we have a slight tweak. We have to figure out the outer function squared minus the inner function squared, and we're still multiplying by pi. Okay, and we figure out the bounds from A to B. Okay, so let's take a look at this example. It says the region bounded by the curve y equals x squared plus 1 and the line y equals negative x plus 3. Okay, so we should be able to easily graph that. Let's take a look. We have y equals x squared plus 1, so we have a y-intercept of 1. Parabola. Y equals negative x plus 3. Negative x plus 3. So negative x will go like something like this. Yeah, something like that. So it's going to be this region then, the region bounded by the curve and the line revolved about the x-axis. So we got to figure out from here to here, it'll be this region. And it's going to revolve about the x-axis. So if you picture the revolving, we're going to have, I got to mirror this somehow. It's not going to look good, but you'll have this this kind of shape going on here. Okay, you'll have something like that. So it'll be this this region that'll get revolved. So we got an outer radius and we got an inner radius. The outer one, as you guys could picture this, the outer one is going to be the line. All right, so capital Rx will be the line. And the inner radius, that will be the parabola. So that will be the x squared plus 1. Now, one thing we have to figure out are the bounds. What are the bounds going to be? So, very easy. We set the two curves equal to one another. Okay, x squared plus 1 equal to negative x plus 3. This looks like it's going to be a quadratic. I bring everything over to the left. So I'll add x and I'll minus 3. Add x and I'll minus 3. So this ends up becoming x squared plus x. 1 minus 3 is negative 2. Equal to 0. And this factors nicely what multiplies to negative 2 adds up to positive 1. We're going to have x plus 2 and x minus 1. That means we get x equals negative 2 and x equals positive 1. Okay, so those are the bounds then. And we got negative 2 to positive 1. Okay. So let's set up the integral. Negative 2, positive 1, pi. We said the outer radius was the line. So that's the negative x plus 3 squared minus inner radius x squared plus 1 squared and then we got the whole thing with respect to x. Okay, so we're going to pull the pi out. Negative 2 to 1. I'm going to expand the squares, right? So I have negative x plus 3 times negative x plus 3. So that'll give me, what will that give me? That'll give me x squared minus 3x is minus 6x plus 9 minus x squared plus 1 times x squared plus 1. That would be x to the 4th plus 2x squared plus 1. We're going to distribute the minus sign into the second half here. So x squared minus 6x plus 9 minus x to the 4th minus 2x squared minus 1. Okay, next we combine some like terms. Right, we combine like terms. We have here, we have 9 and the 1. That'll combine. So that'll give us 8. Then we have, what else? We just have an x term, so minus 6x. We have x squares, so we have x squared and a minus 2x squared. X squared and minus 2x squared, so x squared minus 2x squared is a minus x squared. And then we have a minus x to the 4th. Okay, so now we're ready to integrate it. So we have the pi, 8x minus 3x squared. Now we do x becomes x squared divided by 2, so 6 divided by 2 is 3x squared, minus 1/3 x cubed, minus 1/5 x to the 5th. And we're going to evaluate negative 2 to 1. Okay. So we can plug this all in. We have pi 8 times 1 minus 3 times 1 squared minus 1/3 times 1 cubed minus 1/5 times 1 to the 5th minus 8 times negative 2 minus 3 times negative 2 squared minus 1/3 is negative 2 cubed minus 1/5 times negative 2 the fifth. Okay. Simplifying. 8 times 1 is 8, minus 3, minus 1/3, minus 1/5. For the second half, we have 8 times negative 2, negative 16. Negative 2 squared here is 4. Negative 3 times 4 would be negative 12. Negative 2 cubed is a negative 8. Negative 8 times negative 1/3 will be a positive 8/3. Negative 2 to the fifth is negative 32. Negative 32 times a negative 1/5, that'll be a positive 32/5. Okay, so what do we have? We have here, simplifying a little bit more, 8 minus 3, it's 5. And then let's do in here, after the minus we have negative 16 minus 12, so that's negative 28 plus 8/3 plus 32/5. Okay, so we have 5 minus 1/3 minus 1/5. Now I'm going to distribute the minus sign, so that's a plus 28 minus 8/3 minus 32/5. Okay. So I combine the 5 and the 28, that's 33. Minus 1/3 and a minus 8/3, that's a minus 9/3. And a minus 1/5 and a minus 32/5, that's a minus 33/5. Okay, now the 9/3 is 3, so 33 minus 3 is 30. Okay, so we got to get a common denominator then with the 5. So 30 would become what? Times 5 is 150 over 5 minus 33 over 5. So now we have to subtract what's 150 minus 33. So it's 117. Okay, so then the final answer will be 117 pi over 5. And that would be the final answer. Okay, let's do another problem. This time let's spin it around the y-axis. Right, the region bounded by the parabola y equals x squared and the line y equals 2x in the first quadrant is revolved about the y-axis to generate a solid. Find the volume of the solid. Okay, so let's picture this, what it would look like in the first quadrant. We have x squared and the line y equals 2x. Y equals 2x. It looks something like this. So it's that region. Now to help us, I put the formula, what it would be, just adjusted in terms of y's. Alright, so we have the formula for the volume. That'll be R, the capital R of y, squared minus the smaller r of y squared. So outer minus inner, and we still got the pi and with respect to y. Okay. So then what would this be? We have to then adjust this, right? Adjust these formulas. If we have y equals x squared, we have to write this in terms of x equal in terms of y. So we take the square root of both sides, and we end up with x equals square root of y. For y equal to 2x, I divide by 2, and so I get x equals y over 2. So now picture this as I kind of ran out of room here, but let me see what I could do. And there we go. So as I spin this, picture the curve. You're going to be spinning it around, and so the outer, because you're spinning it around the y-axis, the outer radius will be the parabola. Okay, so r of y will be the parabola one. That's going to be square root of y. The inner one will be the straight line. So that's going to be the y over 2. Okay. The only thing left are the bounds. What would the bounds be? So we have to figure out, okay, where are these the same? So for our functions, we set them equal. We have square root of y equals y over 2. I can multiply both sides by 2. So I have 2 square root y equals y. Square both sides. That'll give me 4y equals y squared. Okay, so I square both sides. If I move the 4y over to the other side, I get y squared minus 4y equals 0. And I could easily pull out a y. Y minus 4. So that means I get y equals 0 and y equals 4. Okay, so that's perfect. Okay, so we know that bounds are going to be 0, and this was the main one we were looking for, the one at 4. Alright, so 4 to 0. Okay, so we have 0 to 4, pi, outer radius function, square root of y squared, minus inner radius function, y over 2 squared, with respect to y. Okay, so we can pull the pi outside. So square root of y squared will just be y minus y over 2 squared would be y squared over 4. Okay, so next, we're ready to integrate. Right, we would have pi, we would have 1/2 y squared minus, that'll be y cubed over 3, so this will be, multiply with the 4, that would be 1/12 y cubed. And then we would plug in 4 and then 0. Okay, so let's do that. So plug in the 4. So we have pi 1/2 of 4 squared minus 1/12 of 4 cubed minus 1/2 of 0 squared minus 1/12 of 0 cubed. Okay, so that tells me that that piece is going to be 0. Right? 0 squared, 0 cubed. That's 0. Okay, so then that means we have pi and then we have 4 squared is 16, so we have 1/2 of 16 minus 1/12. 4 cubed would be 64. Okay, so we end up with, we have pi 1/2 of 16 is 8 minus 64 over 12, which we could reduce. What would that reduce to? 64 over 12. If we divide by 4, that'll be 16 over 12 divided by 4 is 3. Okay, so that means in here we have, if we go common denominator, 24 over 3 minus 16 over 3. So that gives us 8 over 3. And then multiply with the pi. So that would be 8 pi over 3. Okay, that'll be the final answer. End of the video. Any questions you guys have, just write me an email or bring it up during our class meeting. Okay, have a good day, have a good night. See you soon.